Okay, this is our 30 by 30 panel, and we'll wrap it up and do our cocktail hour, which I'm looking forward to. Yeah, however you want to do it, it's fine. Okay, so we've got David Mildrexler, and he's going to be filling in for Bev Law, who unfortunately wasn't here, able to make it today. Bev Law is with Oregon State University, and David is with Eastern Oregon Legacy Lands. Thank you.
Thank you. Thanks, Adam. Thanks to all the organizers. It's been really cool to see this happen. And I grew up in Oregon, and so, I just feel like I want to say that Oregon is just as beautiful a state as any I've ever been to, and it deserves to be as protected as any other state. And I also want to just thank everyone for their great presentations today. It's an honor to follow Paula and Angela, who both do incredible work. And to be on a panel with Andy. And I wish that Bev Law was here today. She hurt her foot while she was in Florida visiting her dad, and so she couldn't make it back. I did give this talk for our group at the fall meeting, AGU's fall meeting, so it was a natural. So thanks for the conference organizers for letting me fill in for her here. And just also want to thank all of you out in the audience that work in conservation. I know how difficult your work can be. And I just appreciate what you do to keep some of Oregon's ecosystems in their potential state. I heard that word today. I really like that way of thinking about our systems. So yeah, my name is David Mildrexler. I'm systems ecologist with Eastern Oregon Legacy Lands. And when I was an undergrad at PSU, forest, carbon, really vegetation, climate interactions, and biodiversity were things that I was totally interested in. So to be able to do this research with Bev has really been a dream come true. And I just want to say that because we roll up our sleeves and go to work on tough issues every single day. We are in the midst of a climate and biodiversity emergency on the planet, and the world's governments have made pledges to deal with both. Targets have been established to protect 30% of the lands by 2030 and 50% by 2050 as intact natural ecosystems. But currently only 6.1% of the conterminous United States is protected at the highest level. So this leads to the question, how do we achieve these pressing preservation targets, given the need to increase carbon removal from the atmosphere, make substantial reductions in carbon emissions, protect biodiversity, and slow the accelerating species losses? It's a lot to prioritize on the same landscape. And we found that when we functionally separate carbon and biodiversity and water, we end up doing things that may benefit one, but inadvertently cause more carbon emissions to the atmosphere. That's why this IPCC joint report was so important. It showed that when we think about these as mutually supporting efforts, protecting the climate system and protecting biodiversity, that's how we can prioritize what actions we need to pursue on the landscape and where. So thinking of these as inextricably connected and also, of course, connected with human futures. So this was a breakthrough in terms of thinking about carbon and biodiversity really need to be planned together as one massive emergency that we're facing now. And we know when we think about forests, we're dealing with systems right off the bat that are crucial in the climate system. Forests account for 92% of the terrestrial biomass on the planet. They provide critical habitats for half of all known plant and animal species on Earth. And about 75% of the world's accessible fresh water comes from forests. Yet few forests are actually consciously managed for these values. And little attention has been given to the nexus of high carbon and high biodiversity forests in the temperate forest zone. There's been more research on the tropical forest and boreal forest, but not so much in our own backyard. But we've been doing some research on this, my research group, and for example, we looked at a wildlife tree policy that was, we heard about today, the East Side Screens that was started in 1994 to benefit wildlife habitat. We found that that policy has made a huge role in protecting carbon in our forests. So we're looking at areas where we're seeing carbon and biodiversity being mutually benefited by policy. Just 3% of the trees in these Eastern Oregon forests are storing almost half of the above ground carbon. And previous studies that Bev Law and colleagues have looked at have identified medium to high carbon density forests in the Western United States, identified areas of relative low vulnerability to fire and drought, and found that high amounts of critical habitat for threatened and endangered species are associated with high carbon density areas. So we've been thinking about all of these things. We're well poised to look at a co-prioritization of carbon, biodiversity, and water, and really thinking about a reserve system. That is, I think, underlying a lot of the 30 by 30 and 50 by 50 thinking, is that we need to protect enough of the Earth system that can support the values and the processes that really uphold life on Earth. So our analysis framework here, we use spatial data sets of carbon stocks and future accumulation under climate change. We used spatial data sets on species and habitat, and then looked at which areas were already protected as GAP 1 and GAP 2, and then looked at what additional areas we would need to protect, prioritizing for carbon and biodiversity to meet those targets. We also looked at areas that were have high vulnerability to drought and fire. In the lower left, you can see most of them are in the Southwest United States, and masked those areas out from the analysis in case we find that it's not possible to meet some of these targets in some places already. So we focused on Western U.S. temperate forests, and also these questions will also flow into the Oregon section as well. How much forest land is currently protected in each stand, and how much additional forest land would need to be protected to reach the targets? Which forest lands are the highest priority for preservation to meet these targets if prioritized based on forest carbon and biodiversity? Who owns the forest lands that have the highest preservation priority? And if these targets were reached, then how much forest carbon and species habitat would occur in protected areas compared with the present? So here's what's currently protected. You can see we're looking at USGS GAP status 1 and 2. Some examples of those areas are provided down below. These are the GAP status that really meet the intent of what scientists are calling for protection, particularly GAP 1. So we looked at GAP 1 areas alone, found that 14% of regional forest area is protected as GAP 1. So we need to protect an additional 16% to meet the 30 by 30 targets. If we loosen the analysis to cover some of the GAP 2 areas that are not as well protected, but they're still on that upper end of protected of protection status, we see that it gets up to about 18.9%, and so we have to additional 11.1% to meet the 2030 goals. And so one thing that jumped out to us right away was that Oregon, highlighted in the red box there, has the most forest extent. You can see 12.68 million hectares, but the least amount of its area protected proportionally. So 10% compared to some of these other states that actually have quite a bit higher amount of their forest protected. So that jumped out right away at us. So the forest preservation priority rank in the upper left-hand corner here was derived from the forest carbon priority rank and the forest biodiversity priority rank below them. We put those into a joint ranking system. And then from that, we sequentially loaded the highest value pixels into every state until the targets were met, which is in the upper right-hand corner. You can see that we were able to achieve the targets in every state. They're highlighted in the dark blue is the 30% preservation. The light blue is the 50% preservation. Where on the ground we would need to protect these forests, prioritizing on carbon and biodiversity to meet these targets. So this was really encouraging to me that we could still do this, even when we mask out the areas of, based on vulnerability, which is shown here, those yellow areas. Note that the highest values are in the mountain ranges, particularly in the southwest, where you get up into higher elevations. In the Pacific Northwest, high PPR values were very well distributed. And so summarizing who owns these lands, you can see a simplification of the areas to protect by 2030 and 2050 on the right there. About 61 to 62% of high preservation priority forest is on public lands. And then about a quarter was in private ownership. We found that substantial progress could be made by protecting roadless and undeveloped lands. Inventoried roadless areas are about 25% of the high priority federal lands. We draw that out because, as you all know, those areas are a known quantity. They're extremely high ecological integrity. We found little difference in ownership patterns across the 30% or 50% preservation targets. And again, Oregon has the most total forest area, but the lowest proportion protected of any state. So here's what we found for how much more carbon and species habitat could be protected if we achieved these goals. So carbon stocks would go up to 34% under 2030 goals, and then 55% when you add in the accumulation, because these protected areas would of course be accumulating carbon within them. You would triple the carbon currently protected in our reserve system. And for species habitat, you can see for the variety of animal or plant taxa, we looked at amphibians, birds, mammals, reptiles, trees, over 1,000 some species habitat. Very few of them have any protections above 20% right now. That would go up to about 30% and 50% respectively with the 2030 and 2050 preservation targets. So large increases in protected species habitat. And of course, water security is a huge issue in the Western United States now. We found that forests account for 56% of the most important area for surface drinking water, but only 19% are currently protected at GAP 1 or GAP 2. Reaching the 30 or 50% preservation targets would preserve about 33 and 53% respectively of these really important areas. So as you saw, Oregon really jumped out at us. You know, a lot of us are based in Oregon, so we really wanted to take a closer look at this. We feel that Oregon is positioned to take significant actions to meet the protection targets and benefit efforts to stabilize climate and protect biodiversity. So we did another study. We looked this one at 30-meter resolution. The other one was at 1 meter. Again, we prioritized with an eco-regional distribution. So whenever we're looking at these high priority carbon areas, we're ranking them within each eco-region separately. So we're not getting, for example, all of the coast range loaded up for the highest carbon areas. We're prioritizing every single ecoregion separately. And we think that's very important for a well-distributed reserve system. And we added a resilience metric as well. There on the lower right-hand corner is the resilience metric. We wanted to add that in because a lot of research shows that these places are associated with topographic features that are going to be stable with climate change. And so we expect these places to be quite stable. The biodiversity rank and carbon rank are shown there on the right, and all that was put into this preservation rank. For me, I don't know, and other these are freely available data sets. These are beautiful spatial data sets showing the distribution of these variables across the state, spatially continuous. And so this is what it looks like when you put the existing protected areas on top of the map for strategic forest reserves for the state of Oregon. You can see the areas in dark blue we need to protect by 2030, the areas in light blue protect by 2050. 67% of those areas are on public lands in Oregon, and 25% that we need to protect by 2050 are on private lands. There's a little bit of state and tribal land in there, but certainly dominated by federal public lands and private lands, which was also what we found at the Western U.S. level. So for these variables here, for forest habitat, carbon, and drinking water protected, currently only 9% of the state's surface drinking water source areas are protected. We would increase that to 27% and 48% respectively by achieving these targets. Tree above ground carbon would go up from 12% in protected areas now to 45% and then to 70%, which really speaks to the benefits of this prioritization. And the species habitat protected would go up from 10%, which is really quite poor when you think about how much species is currently protected, well protected in Oregon, up to 27 to 42% for animal taxa, and 41% for tree species at the 2030 targets, and then on up to into the 50s and 60% for animal and tree species if we achieve these targets. And so in our paper, we looked at a variety of places in Oregon that I know you all are very familiar with. And it just really, when you look at some of these big, well-protected areas, oftentimes you'll see that the roadless and undeveloped and intact lands are often right next to these areas because these areas were rugged, they were remote. That's part of the reason why they were protected in the first place. So we were starting to think about what areas to protect. How do we continue to build on these protected areas, and what's unique and special about all of these distinct regions across the state? One of the key messages that Bev asked me to convey to all of you was, of course, this eco-regional prioritization, which is so important for a well-distributed reserve system. Also, that Gap 1 protections are absolutely crucial to success. The Gap 2 protections will likely be, people will find excuses to go in there and log, and we need these areas to actually function as climate and biodiversity refugia, not just on paper, but in reality. So Gap 1 protections are crucial. And so as we look at this, it does still open up the question, how do we translate this data into a vehicle for a citizen's proposal? I mean, these spatial data sets are amazing. They're beautiful for scientists, but there is a translation gap, I think, here. And so one of the things that we found in one of the places that we highlighted was the Blue Mountains. And as we've heard today, Eastern Oregon has some of the most forest in Oregon. The Blue Mountains is Oregon's largest ecoregion. So to be successful, we're going to have a lot of protections in the Blue Mountains. And this was perfect for me because I've been living and working on this ecoregion for quite a while. So now we will switch gears into the talk, my next talk here, an enduring conservation vision for the Blue Mountains of the Pacific Northwest region. So there's just an incredible place that we all know and love, interspersed mountain ranges, valleys in between, reaching across the entire state. And there's really no holistic vision for this landscape at all. And we've been working to develop one because we really need a vision that accounts for this incredible ecoregion. So let's talk about that here today. We've talked about strategic forest reserves. Now I want to jump into the Blue Mountains. The Blue Mountains, viewed here in context of the Pacific Northwest region, that is the level 3 ecoregion. That to me is the smallest unit at which I like to study the Blue Mountains. With that scale, as an Earth system scientist, I can plug it in or fit it into the rest of the world in a very specific way. It ties into the Cascades, it ties into the Northern Rockies, and so it's providing a forested corridor across these massive mountain ranges, which is very unique. If you look at other ecoregion maps, you'll be hard-pressed to find one that in one ecoregion connects two massive mountain ranges with a forested linkage. Eastern Oregon's forests, that we've heard here today, are incredibly diverse. Just look at the forest type groups are all on the left, all the different colors that you see. Of course, we have juniper and ponderosa pine, but look in the central and northeastern blues, how you start to see dominance of fir, spruce, mountain hemlock types. And as we heard from Paula and Angela, all of this can mix also within very close places on the landscape. And some of that distribution that you saw with more fir, spruce, hemlock in the northeast is driven by this incredible flow of moisture and air that comes through the Columbia River Gorge, the largest river by volume emptying into the Pacific Ocean out of North America. It cuts a chasm through the Columbia River Gorge. I grew up on the east side of Portland. We used to get blasted by those ice storms. This thing is powerful. And the Blue Mountains receives a lot of that moisture in the northeast corner. And of course, also gets moisture from orographic uplift throughout, but a lot of the system has to move over the Cascades, So we get this huge hydrological gradient across the Blue Mountains, and also this incredibly dense stream network across the Blue Mountains. So it's feeding the rest of Eastern Oregon by collecting water, lots of complex stream networks that then feed off into the Columbia River Plateau and the Great Basin. And then when you put it all together, we've seen this map a little bit earlier, this migrations in motion map shows that when you look at the average direction that mammals, birds, and amphibians need to move to track these climates across the landscape, a lot of these flows are north-south, but then you get up through the Blue Mountains and there's a hard curve there right through that ecoregion. And so that, you know, and again, though, this is the direction that species need to move, not necessarily that they can. And so when we look at this reserve system across the Blue Mountains ecoregion that is supposed to support those species, habitats, and their movements, what we find is it's highly isolated. This is just showing simple distances between protected areas. I assume you guys know pretty much what those are the wilderness areas in the Blue Mountains. And I was just surprised, 40 miles between the Hells Canyon and Wenatah Canyon, not to mention private lands, 46 miles between the North Fork Umatilla and the North Fork John Day. And of course, in this part of the Blue Mountains, the reserves are much smaller and they're all separated. So this is not a reserve system. This is isolated, disparate, protected areas that cannot support the functionality of this system under climate change. And this is what the road system looks like when you put it in there. So we're dealing with some of the most roaded national forests in the nation. We've heard about that, high road densities. And so it's a lot of challenges working in this landscape here. And it just increases the need for us to take action so that this ecoregion can actually function to its potential. But good news, there's a lot of roadless area left in the Blue Mountains. Okay, and so when we looked at this, the Forest Service missed a lot of areas in the 1980s. I can't blame them. I mean, the satellites we worked off for my master's degree weren't even launched till 2000 and 2002. This is the 1980s. They missed a lot of roadless area, and there was probably other reasons too. So there's actually twice as much roadless area out there as there is protected wilderness area. And we know exactly where those places are in the landscape. They're mapped in dark green here. Notice how they form almost like a connective tissue in between the rest of the reserve system. And just by putting those on the map, you can actually start to see how the landscape is actually working now and trying to work as part of a connected reserve system. And you know, these are some of the best remaining habitats out there on the forest. So if I zoom into an area that is in between the Wenatah Canyon. Zoom into that area, you can recognize those shapes. Angela talked about Joseph Canyon and the Wild Horse roadless areas and the Nez Perce precious lands. So they're right in between these big wilderness areas. And if you look at the resilience data, you'll see incredible correlation between the roadless areas, not just there, but all around there, and the Eagle Cap Wilderness, the Hells Canyon, and all of these roadless areas are actually connecting the landscape together with high resilience. And I would just want to note that our Camas de Condors project is focused around precious lands and Joseph Canyon. And I get to work with Angela and a lot of great people in this project. And, you know, we're thinking about the values of these landscapes in whole different ways. And we're realizing the potential for creating economies and connecting indigenous youth and thinking about restoration and bringing back condors. There's so much potential untapped in these landscapes that we're finding when we start to actually look and build partnerships and programs around them. And when we back up and look at the whole system, there are efforts to create like there's a new trail system called the Blue Mountains Trail that is designed actually to go through many of these roadless areas and to showcase their values. So it's another way that we're starting to see the idea of connections coming around. Like a trail is connective and it goes through all of these areas. So we're getting more and more thinking about how do we connect this landscape and protect the areas that we need to. And these are some of the places that you know, some protected to some degree and some not. The mountain watersheds that are just full of snow right now across the Blue Mountains, they've been working really hard. Forests like this that look like you're in the Coast Range, but you're actually at low elevations in the Eagle Cap Wilderness or outside the Eagle Cap Wilderness. And these roadless areas cover different elevational gradients. Major river corridors we could still protect in the Blue Mountains, natural disturbance processes, wildlife functioning. And these incredible ancient forests right here in the Lookout Mountain roadless area, which I've never gotten to see in person, but I heard all about it in the Imnaha River Corridor with these big ancient trees. And of course, these big wildlands in the Hells Canyon that are just incredible and just mind-blowing, the expanses of them. So when we look at some of these protected areas and think about these targets and the people that work to their entire career to direct us to connecting landscapes and protecting landscapes and half Earth, these are some of the principles. As reserves grow in size, the diversity of life surviving within them also grows. More intact areas are better, less edge. We don't want a lot of edge. Habitat connectivity between reserves is essential, and we need places where ecological processes can function. Thank you.